So section 4.7 is triangle inequalities. Across from the largest angle in a triangle is the longest side, and across from the shortest angle in a triangle is the shortest side. And this is called the hinge theorem. So theorem 4.10 can also be called the hinge theorem, because if you think about hinges on a door, the wider you open the door, the longer the length from the door to the door frame is going to be, right? If you shut the door, the smaller the length is going to be. So side BC here is 5 units long, and side BA is 3 units long. So angle A is across from side BC. So angle A must be bigger than angle C, since 5 is bigger than 3. So angle A is bigger than angle B. So name the angles from the largest to the smallest. So the largest angle is going to be across from the largest side. So the largest side here is side TV, because it's 10, and across from that side is angle U. So angle U is the biggest angle. Next biggest side length is 8, and that's side TU. Across from that side is angle V, so that's the next biggest angle. And last but not least, across from the shortest side, 4 is angle T, so that is our smallest angle. Again, largest to smallest. So our largest side is our largest side is 17, which is side LM, and that's across from angle N. So angle N is the largest angle. Second longest side is 14, which is across from angle L, which means that angle L is the next biggest angle. And last but not least is our shortest side, which is 12. 12 is across from angle M, so angle M is the third biggest angle. Make sure when you name angles, you put the angle sign. Now the opposite is also true. Across from the biggest angle is the biggest side. So angle D is 60 degrees, which means that EF has to be bigger than side DF, because 60 is bigger than 40. So EF is going to be greater than the length of DF. So name the sides from longest, shortest. So my longest side is going to be across from the biggest angle. So my longest side is side DF. And we always write sides as segments because it has 2 endpoints at D and F. My next biggest angle is 57 degrees. So across from my 57 degree angle is side EF, so segment EF. And then my smallest angle is 37 degrees, and that is across from side DE. So that is my shortest side, since it's across from the smallest angle. Again, name the sides from longest to smallest. It's not always going to be longest to smallest or longest to shortest. Sometimes they might switch it up in homework, quizzes, so just make sure you read the directions and pay attention to those. So the longest side is going to be across from the biggest angle, which is 78 degrees. So the longest side is side DE, so segment DE. The next biggest angle is 54 degrees, which is across from side EF. So EF is the next biggest side length, and the shortest side length is across from the smallest angle, which is side DF, or segment DF. Last theorem in this lesson says that the sum of the lengths of any 2 sides of a triangle is always greater than the third side. So you pick any 2 side lengths in a triangle, add them together, it has to be bigger than the third one. And here's why. So if you have 3, 5, and 9, 3 and 5 are the 2 smallest sides. So if you try to bring these down to make a triangle, they're not quite going to reach, right? Because there's 3, there's 5, and there's this little extra 1 here. And so it doesn't make a triangle. Now what if the bottom is 8? So if we have 3 and we bring that all the way down to try to make a triangle, and we have a side length of 5, those are never going to meet either, right? They will touch at the bottom to make a length of 8, but that's not going to make a triangle. So 3 plus 5 is 8. If 8 equals 8, that's still not big enough to make a triangle. But if our bottom length is 7, now, right, eventually this side that's 3 units long and this side that is 5 units long are going to meet, and it's actually going to make this, oops, it's actually going to, whoops, it's actually going to make this triangle right here. Okay, that's because when you add the two smallest sides, 3 plus 5, you get 8, and 8 is bigger than 7, so it allows the sides enough room to touch to actually make a triangle. So can the side lengths form a triangle? What you need to check is, do the two smallest sides add up to be greater than the third side, which is the biggest side? So take your two smallest sides, add them together. 5 plus 7 are the two small sides. Add them together to get 12. Is 12 bigger than 13? No. So then it can't form a triangle. 12 is not greater than 13. So no, these side lengths cannot form a triangle. So take your two smallest sides, 6 and 9, and that gives you 15. Is that greater than 12? Yes, 15 is greater than 12. So yes, these three side lengths can form a triangle. Okay. Add up your two smallest sides. 10 plus 15 is 25. Is 25 greater than 25? No, it's not greater. It's equal, but it's not greater. So therefore, these three sides cannot form a right triangle. Right, the 10 and the 15, picture those. They would never meet until the bottom, so they wouldn't be able to form a triangle. And that's it for section 4.7, triangle inequalities. Now, just make sure you don't confuse this. In the beginning of this chapter, we talked about Pythagorean theorem. Pythagorean theorem is used to find the missing side length of a right triangle. Then we learned how to classify a triangle. So we checked, is c squared greater than, less than, or equal to a squared plus b squared? And let me pull something up here real fast. So this is what I just talked about, Pythagorean theorem. And then classifying triangles, is c squared greater than, less than, or equal to a squared plus b squared? If c squared is greater than, it's obtuse. If c squared is less than, it's acute. And if it's equal, then it is a right triangle. And then this is what we just learned today. Can the side lengths form a triangle? Do the two shortest sides add to be greater than the longest side? If they do, then yes, they form a triangle. If they don't, then no, they do not form a triangle. So make sure you keep these three ideas separate.